Hello, water managers. My name is Kat Feingold, part of the Water Management Systems Division at the Hydrologic Engineering Center. I'm going to be covering real-time data in SWMS in the short series of presentations. The objective is at the end of these presentations, you will be able to identify the types of real-time data and their management in SWMS. This series is broken down into 4 separate videos. The first one, we discussed the 2 types of data available for viewing and utilizing in SWMS, time series and grids. The second video discussed where to get that data. This video is going to cover the processing of that data. And then the final video is going to cover the storage systems and the acquisition of that data. As discussed in previous videos, there are 2 types of data available in SWMS. Time series and gridded data. First, we're going to take a look at the time series data processing. So time series data is obtained and transformed in a variety of ways. So time series can be obtained from direct observation or they can be derived. Examples of time series from direct observation include river gauges, precipitation gauges, thermometers to give you stage gauge, precipitation, and temperature. Examples of time series using derived ability, utilizing those direct observations and computations, would be deriving flow from a stage and rating flow, or storage from an elevation and storage curve. So within SWMS, there are several tools available for processing and modifying time series data. SWMS and MetVue Data Validation Editor, the SWMS Computational Processor, otherwise known as the CCP, and the DSS math functions and scripting. So first, we're going to take a look at the CAVI SWMS-Vue DSS-Vue Validation Editor. So if you take a look here, this is what the Data Validation Editor looks like. And these crosshatch green areas are everything that you have selected inside the tabular information below the graph. So inside the Data Validation Editor in the CAVI, you can estimate missing values. You can estimate all of the values. You can choose to accept the values there, and it will go ahead and place it in the revised column. You can add a data point, you can delete data that's already there, or you take a whole set of missing data and you can fill it with a variety of options. You can do linear, repeat, or raw fill. In addition to all of that, you can select as much of the data as you'd like, and you can either add a constant to it, or you can add a multiplication factor and then accept that data. And you always have the option to clear all of the data that you have entered. So this brings us to the OpenDCS SWMS Computational Processor, or CCP. So CCP goes through a process application. So it takes your time series data and it looks at it and it kind of looks at everything available and finds the computations that you have identified that depend on that data. And then it goes ahead and it executes those computations and retrieves additional data that's necessary. And it continues to do this until it has results, which then get stored back into the database and then get pulled back in any time that they are needed again. So some of these examples are you can average across time series, you can take a point and fill forward from that point in your time series, you can disaggregate an entire section of time series, you can create complex inflow computations. For those of you who are interested and would like more information on the SWMS Computational Processor, CCP, there are references here available for you to review. They will also be available in the description below. The final piece of time series data that you can process within SWMS is utilizing DSS math functions and scripting. So some of the basic examples is estimating missing functions, replacing values, using minimum maximum as screening points, converting time series from irregular to regular, moving the average. In essence, anything that you can script, you can do. So As long as you do it logically and can script it, it is available as a process within SWMS. SWMS is scripted in Jython, which is a combination of Java and Python. If you are looking for scripts, user manual, or additional information, please feel free to go ahead and take a look at the references here on this slide. Again, these references will also be copied over into the description below. So if you are a scripter and you can dream it, you can do it. This brings us to the next type of data that we discussed, which is the gridded data. So grids are obtained and transformed in a variety of ways, as we discussed previously. And just like time series data, you can have direct observations and derived data. So examples for your direct observations are going to be anything from radar or remote sensing, either satellite or aircraft or gauges. So grids can also be derived from these observations, either the gridded data, or you can take point data and go ahead and interpolate them. So some of the ways that you can do this, some of the examples are interpolation from point measurements across a field, model results, plugging and missing data. There are a number of data processing available. So there's a number of derived grids that are also available. So you have your QPE, QPF, but you also have a couple of grids that are available, again, on Cumulus. One of the examples of this would be the MRMS, which is the multi-radar, multi-sensor, where they basically ground truth their radar and combine it with real-time calculations. And then you also have the SNODAS, the Snow Data Assimilation System. So both of those are derived grids from available observations that you can download directly into the CAVI. However, what if you have something that you would like to adjust that you didn't just download and import? So HEC-MetVue is going to be your primary processor for gridded data. So with HEC-MetVue, you can fill in missing data, merge data sets, you can do temporal aggregation and disaggregation, you can do spatial aggregation and averaging, you can also do tins to grids, grids to tins, and you can finally interpolate point data to gridded or tin data through a variety of methods, either inverse distance squared, nearest neighbor, or bilinear. So all of these things are available to you in HEC-MetVue, and there will be a later presentation given by another member of HEC that will go ahead and discuss the finer points of HEC-MetVue. So this is just kind of a visual look at what HEC-MetVue can do. An example of the temporal disaggregation is in the top left corner, as we discussed. You're filling missing data directly below that, and then you can take data sets and actually merge them. You can take your observed and forecast and merge them together. So that is another form of processing that is available to you in HEC-MetVue. And finally, you have the spatial interpretation below, which is where they have that point data and they've interpolated it over a vast area. Video, we're going to go ahead and cover the SWMS data storage systems and acquisition. However, if you have any questions about our software, need some help, or are looking for additional training, please feel free to check out these links. They can also be found in the description below. Thank you for your time.